This is video 2 in the test 2 review. So here we have this transfer function h of s is equal to 2s over 5s plus 1. And note, I'm using a first order system just to make it simpler to go through this review because I don't want to take a long time. But you should be able to work with, say, second, third, type order systems, right, or higher. It doesn't fundamentally get more complicated if, for instance, I had an s plus 1 times an s plus 4 in the denominator. Yeah, you have to do some partial fraction expansion, but it's the same tools that we're using. So for the sake of expedience here in this video, I'm going to use this simpler example, but make sure that you can work a higher order system, second order certainly, and even a third order. Okay, so we have this system, and we're going to say that the input x of t is going to be a unit step. Okay, so we're going to try to answer some things going down our list. So we talked about pole zero. So pole zero plot is pretty straightforward. We got the real and imaginary axis, and we're going to put zeros wherever, or circles wherever there are zeros. In this case, at s equal to 0 because of the numerator there. And then we're going to have a pole at s equal to minus 1/5. So minus 1/5, and that's the extent of our pole zero plot. Okay. Now what is y at time 0? Okay. Well, we're going to use the initial value theorem. Okay, so we'll say this is equal to the limit as s goes to infinity. So at time 0 we go to s equal to infinity of s times y of s. And y of s here is going to be equal to h of s times the Laplace transform of the unit step, right, which is just 1 over s. So we have 2s over s times 5s plus 1. The s's cancel out, and so now we see that y at time 0 is going to be equal to 2 over infinity, right? 2 over infinity. So we actually have an initial value of 0. Oh, wait. I forget, that doesn't look right. Okay, I forgot the s times here. All right. So sorry. So let me rewrite that with s out front. Okay, limit as s goes to infinity. Okay, so we'll end up now with we'll have 2s squared over 5s squared plus s, and then we'll let s go to infinity. Right? And then we see here that it's going to go to 2/5. Okay, initial value of y will be 2/5. All right, now for the final value. All right, for t going to infinity, we'll use the final value theorem. Which says that y at infinity is going to be equal to the limit, as s goes to 0, of s times y of s. And so here we have 2s squared over 5s squared plus s going to 0. And clearly that's going to go to 0. So y at infinity is equal to